In this lecture, we'll go through the commands to draw three-dimensional objects in AutoCAD, such as the points, lines, boxes, cylinders, cones, and so on. In three-dimensional space, the generation of points is very similar to two-dimensional drawings. You can still call the command point to generate multiple points under the 3D environment. And if you want to change the type and size of the points, you can also call the command ptype. These are exactly the same to the two-dimensional drawing. The only difference is that under the 3D environment, you have to use the 3D rectangle or polar coordinates to identify the location of the points. For the lines in the three-dimensional space, we can still use the line commands to define a single line. But if we want to generate a polyline under the three-dimensional space, you have to call the command 3D poly. If we want to modify the property of the 3D polyline, you have to call the command pedit. And this command is exact same to the two-dimensional polyline editing command. The settings, including close join with, edit vertex, and so on, are exactly the same to the two-dimensional drawings. In this demonstration, I will show you how to generate the three-dimensional points and lines. First, for the points, we can call the point command. And then we can specify the location of the point with the three-dimensional coordinates. Say the coordinate is 3, 5, 4. So the x coordinate is 3, y coordinate is 5, and the z coordinate is 4. Now we define one point on this three-dimensional environment. Here, the type of the point is a dot, so you cannot see this point clearly. In that sense, we have to modify the type of the point. That's called the ptype command. And then we can specify the type of the point. Say the point size is 10%. And then you will have the clear view about the point we just defined. Second, for the line command. Under the three-dimensional environment, we can still use the line command. But it seems that if we want to specify the directions and the location of the line, you have to use the three-dimensional coordinates. For example, for the first point, we will use 0, 0, 2. That's the first point. And then we can specify the second point with the rectangle coordinates 6, 7, 4. So that's the definition of one three-dimensional line. If we want to generate a three-dimensional polyline, you have to call the command 3D poly. With this one, you can specify the origin of the polyline at first, say it's 5, 5, 2, and then you can specify the location of the second point, 6, 4, 1. With the rectangle coordinates, you can also use the polar coordinates. That would be 10 less than 1 angle, 60 degree less than second angle, 30 degree. And that's the way for you to specify the second line segment under this polyline. So this would be the generation of the three-dimensional lines. Under three-dimensional space, you can also draw the two-dimensional objects such as the rectangle, circle, polygon, and so on. The operations of these objects will be exactly same to two-dimensional drawings, so we will not discuss about these objects in the chapter 7. In this lecture, we will just focus on the three-dimensional objects. The first object we will learn is box. The command for us to generate new box is just a box. Under this command, you will have several methods for you to generate a new box. The default method is called corner. So here you can first specify two corners to identify one rectangle, and this rectangle will be used as the bottom of the box. And then you can specify the third corner, which will be used for you to specify the height of the box. And that's the way for you to generate a new box. You can also use the other method, center, cubic, length, width, and height, to define new box. Now let's see the generation of boxes. As I just explained, we can use the command box, or you can go to the 3D tools find out the box icon, and then you will have the different method to identify the box. The first one is corner. So you can specify the first corner, second corner, and then define a height to identify a new box. The second one is called center. With this one, you can specify the center of the box. So first you define the location of the center, and then you will specify one corner of the box. And the next step, you have to identify the height of the box. Then you will complete the generation of the box. Remember, the first point you just defined is just the center of the entire box. The third method is called a cube. With this one, you can just define a cube based on the definition of the length and directions of one edge. And then you complete the definition of a new cube. The last method is called the length, width, and height. So you can first specify the length of the box. Say the length is 10 units, and then specify the width. Say it's 5 units, and the height. Say it's 6 units. And with that way, you can define a box precisely. The second object we will learn is a sphere. To generate a new sphere, we have to call the command sphere. And under this command, you should first specify the center of the sphere. And then you can either define the radius or the diameter of the sphere to complete the generation. If we are complete the joining under the two-dimensional wireframe style, then the whole object will be described with the lines. The default number of the lines is 4 for the three-dimensional environment. And you will see that 4 lines is not sufficient for you to describe a sphere. So if we want to increase the number of the lines, you have to call the command isoline. And then you can define as large number of the lines as possible. The value can vary from 1 to 2047. With a high number of the lines, the objects under the two-dimensional wireframe style will be more realistic. Now let me show you how to generate a sphere in the three-dimensional space. To generate a sphere, we have to call the command sphere, or you can go to the 3D tools, choose the sphere icon, and then you can specify the center of the sphere. And next step, you can identify the radius or the diameter of the sphere. Say the radius is 5 units, and then you complete the definition. Here under the two-dimensional wireframe, you will only use the lines to represent the sphere. And in this picture, you can see that it's not a quite realistic sphere in the three-dimensional space. So if we want to make the picture more realistic, you have to increase the number of the lines. So we need to call the isoline command and specify the number of the lines as 20, or you can set some higher value. And then we can generate a new sphere. And this one will be more realistic with 20 lines. You also have some other method to define new sphere. The first method is 3 points. With this method, you just need to identify any 3 points on the sphere, and then you can generate a new sphere. The second method is 2 points. In this method, you just need to specify the line crossing the center of the sphere. And that's the second method. The last method is called a tangent radius. So with this method, the sphere will be tangent to 2 objects, and then you have to define the radius of the sphere. For example, we specify the first tangent location is here, second tangent location is here, and then you can identify the radius, say it's 6 units, and then you define a new sphere, which will be tangent to that 2 straight lines, and the radius is about 6 units. So that's the generation of the sphere and the changing of the isolines. The third object we will learn is a cylinder, and the command is just cylinder. With this command, we can generate cylinder with either ellipse or the circle base. To generate a new cylinder, we have to first identify the center and the radius or the diameter to identify the base, and then we just need to specify the height of the cylinder. And with these three parameters, we can complete the generation of a new cylinder under the three-dimensional environment. Now let's see how to generate a cylinder in AutoCAD. We can call the command cylinder, or you can go to the toolbar and choose the cylinder icon. Actually, the default base of the cylinder is in a circle, so you can use the general method in the two-dimensional space to define a circle such as the center plus the radius or the diameter, 3 points, 2 points, tangent radius to identify a circle. Here I'm using the center plus radius to define the base with the radius of 5 units. And then you just need to identify the height of the cylinder, say the value is 10 units. And that's the way for you to complete a new cylinder. If you want to generate a cylinder with an elliptical base, you have to choose the option elliptical. And then you need to define the ellipse as the base. The operation is exactly the same to what you are working on in the two-dimensional drawings. And then specify the height. And that's the way for you to generate different types of the cylinders in AutoCAD. The next three-dimensional object we will learn is cone, and the command is just a cone. Basically, the base of the cone can be either circle or the ellipse. You can use the regular two-dimensional drawing skills to complete the base. And then you just need to specify the height or the top point to complete the generation of a new cone. In order to generate a new cone, you have to call the command cone or go to the toolbar and find out the cone icon. And then you have to specify the base. It could be either the circle or the ellipse. So here I will just focus on the introduction about the cone with the circular base. And then you just need to identify the location of the top point or the height of the cone. Say the value is 15 units. And then you complete the generation of a new cone. Also, with this command, you can generate a flat top for this cone. Still, you will call the cone command, define the base, and then you can identify the top radius. Say the top radius is about 2 units. And next step, you can identify the height of this cone. Say the value is 12. And now you complete the cone with a flat top. You can also generate a cone with an elliptical base. The method will be quite similar to the generation of the cylinder. The wedge is another important three-dimensional object. The command for us to generate this kind of object is just a wedge. Actually, wedge is a half on a box, so the setting on the wedge is exactly the same to a box. The only thing you have to know is that the higher side of the wedge is always associated with the first point you defined for the object. And also, the edge here is always parallel to the y-axis. So in order to insert a wedge to your current drawing appropriately, you have to carefully define the first point and also the direction of the y-axis. Now let's see the generation of a new wedge. So you have to call the command wedge or go to the toolbar, choose the wedge icon. And then you have to first specify the base of the wedge. First point, second point, and remember that the higher part is always associated with the first point and is parallel to the y-axis. So when you set up the height, this line is always parallel to the y-axis. And let's see another example. Specify the first point, Second point, it's always parallel to the y-axis. And if we want to put the higher side to this way, you need to revise the y-axis. So you have to go to the user coordinate system and specify the method as z-axis and rotate the entire coordinate system about negative 90 degrees. And then let's see the new wedge. First point, second point, the wedge is placed at this side. So that's the way for you to generate a new wedge, and you have to carefully handle the directions of the y-axis and the first point you define. The torus is also commonly used in three-dimensional drawings. The command is just the torus. Actually, the generation of the torus is very simple. First, you have to specify the center of the torus, and then you have to identify the radius of the axis for the torus, or the diameter for that axis. At last step, you just need to specify the radius or the diameter of the pipe. So we have 1, 2, and 3 steps to complete the torus. And if you are under the 2D wireframe style, you have to carefully define the number of the lines. So you need to go to the ISO lines so that you will have a more realistic view about the torus under the 2D wireframe style. Now let's see the generation of a new torus. First, let's change the number of the ISO lines. Say the value is 30. And then we can call the torus command, or you can go to the toolbar, find out the torus icon. First, you have to specify the center of the torus, and then define the radius. Say the radius is 10 units. And next step, you have to specify the radius of the tube or the pipe, or the diameters. Say the radius is 2 units. And then you complete the definition of the torus. And actually here we will have 30 lines to represent the surface of the torus so that you can see the realistic effect of the torus in the modeling space. The last three-dimensional object we are learning the pyramid. The command is just a pyramid. Actually, the base of one pyramid is a polygon. So to define the base of the pyramid, you have to first identify the number of the sides, and then use either the inscribed or the circumscribed method with the radius, or the edge method to identify the size of the polygon. At last step, you just need to specify the height of the pyramid to complete the generation. Now let's see the generation of one pyramid. First, you have to call the command pyramid, or you can go to the toolbar, find out the pyramid icon. And then the first thing you need to do is specify the number of the size. For example, if I say the number of size is 5, and next step, you can use either the circumscribed or the inscribed method or the edge method to identify the polygon. This one is the same to the polygon you define in the two-dimensional modeling space. And next step, you just need to specify the height of the pyramid, say it's 6 units. And that's the generation of one pyramid. This command also provides us to generate a pyramid with a flat top, which will be quite similar to the cone command. So you go to the pyramid icon, specify the base, and then define the top radius. Say the top radius is 2 units. And then you just need to identify the height. Say it's 10 units. Now you complete the generation of one pyramid with a flat top. At the last of this lecture, I will show you how to use all the previous commands we learned to complete the three-dimensional design here. This is the design we want to complete in the example. Right now we observe all the objects under the conceptual style. But if we want to draw all the objects accurately, you have to change it back to the 2D wireframe. In this design, we can see that the base is in the box. So we will first call the box command and draw this base. Specify the location of the base and define the base of this box and specify the height. And next step, we will draw this wedge. Here you see that the higher side of the wedge is actually parallel to this edge. In that sense, we have to define that y-axis is parallel to this edge. So we need to call the UCS command to define new coordination system. Specify the face and choose the top of this base as the plane for us to define the new user coordinate system. And then accept this one, call the UCS again, specify the Z method, and rotate the coordinate system about negative 90 degrees. Now we can call the wedge command. Specify the first point and the second point. Now you will see that the higher side is actually parallel to this edge. And next step, we will draw the box with the cone on the top. So we call the box command. Draw a small box and then call the cone command. Specify the center of the top plane for this box. And identify the height as 5 units. Now you can copy these two objects to the left side of the wedge. The displacement is this segment. And next step, we can complete the back side of this design. First, we will draw an torus. And then specify the radius of the pipe. Now we can draw two pyramids on each side of the torus. Specify the number of the sides as 4. And then define the first. Specify the height, say it's 5 units. And the second one, the height is 5 units. And next step, we will draw a larger pyramid inside of the torus. And the center of the base for the pyramid is the same to the center of the torus. Say the height is 20 units. At the last step, you just need to draw a sphere and make the center of the sphere as the top point of the pyramid. Say the radius is 5 units, and then you complete the design in this example. After class, you can make the practice by yourself and specify the dimension by yourself to see how you will use all these commands we learned in this lecture. This is the end of the second part about the three-dimensional drawings. In this lecture, we learned some fundamental 3D objects. So after class, you can go through all the commands you learned in this lecture and make more practice about the drawings of the 3D objects, especially about how to use different methods to draw the same 3D objects.